Good morning, chemistry students. Today we're going to learn about how to name and write formulas for acids and bases. Now this is a little different from what we've done before. We've done molecular compounds and we've done ionic compounds, and so some of this might look a little different. So I'm going to show you up front some examples of acids and bases and their names and formulas, and see if you start to recognize some patterns. Maybe some things will look familiar about this. And then I'm going to give you instruction on how to do this, and then we'll do some practice problems. So here we have a first column where you are to identify whether something is an acid or a base. Then we're writing the name, then we're writing the formula. So the first one here is sodium hydroxide. Sodium hydroxide is a base, and it has a formula, NaOH. Here's an acid. It's called hydrochloric acid. Well, recognizing that something that ends in acid is pretty easy, that's an acid. So that's pretty simple. And the formula for it is HCl. Here's another acid. It also ends in the word acid, so that's pretty obvious. This one is called chloric acid. This is hydrochloric acid. This is chloric acid. Chloric acid is HCO3. Here's another base. This one is magnesium hydroxide. Mg parentheses OH parentheses 2. Hydroxide, base, hydroxide, base. That should help. And here's another acid. We recognize acid in the name, so that's obviously an acid. This is sulfuric acid, and it has the formula H2SO4. So let's talk about how you decide what the formula is and what the name is for acids and bases. Okay, so we're going to talk about how to determine names and formulas for acids and bases. So here we go. Acids and bases are two unique classes of compounds. Their behavior and reactions make them stand apart from other chemicals, and because of that, they've got different ways of being named. To identify them by their name or formula, use these general rules. An acid name ends with the word acid, as you saw in those examples, and their formula starts with H, and you can see some examples behind me. All the ones that end in the word acid start with H. Base names end with the word hydroxide, and their formulas end with OH. In fact, you can see behind me up here, we've got NaOH, and down here, it's backwards for me, we have Mg in parentheses OH 2. So it ends in OH even though there's a subscript number after it, sometimes. Bases are really easy. We've already learned to name bases, although we didn't identify them as bases. So bases are ionic compounds. They start with a metal, and they always have hydroxide as their anion. This is technically true for many bases, but it's really a bit of an oversimplification. There are things that are bases that don't end in hydroxide, but they're kind of rare, and we'll get to that later when we have our acid and base unit. Acids are molecular compounds, but they're formed like ionic compounds. Their formula is made from the H plus cation and then any other anion. Charges get balanced just like in an ionic compound. So here are some examples. H plus cation always for an acid. And the anion in this one is going to be Cl minus. And H plus and Cl minus, plus 1 minus 1 balances out. So this one is going to be HCl for the formula. In the next one, we've got H plus as our cation, of course. S minus 2 for our anion. Sulfur is a negative 2 ion, of course. So to balance the charge here, we're going to need 2 hydrogens to go with 1 sulfur. So our formula will look like H2S. And here's our H plus cation again, of course. And what if we had SO4 minus 2? This is the sulfate polyatomic ion. If you look on your polyatomic ion sheet, which is in the course information folder if you aren't sure where to find it, you'll see that this is called sulfate, SO4 minus 2. But it's a sulfur and 4 oxygens, and the whole thing altogether has a minus 2 charge. So again, we're going to need 2 of the H plus to go with it to neutralize it. So H2SO4, and oops, there it is behind me. And that one's sulfuric acid. Binary acids are formed when H plus, from H plus and an elemental anion. So not a polyatomic ion, just one element with a charge. And their names, binary acids names, are hydro something ic acid. And the something, of course, is the name of the element. So HCl is going to be hydrochloric acid. Now it's really chlorine, so we take off that ene ending and add the ic. So hydrochloric acid. The next one we're going to look at is H2S. This one is going to be hydrosulfuric acid. And then H3P is hydrophosphoric acid. And HBr is hydrobromic acid. So the binary ones are pretty simple. The ternary acids are a little more tricky. They're formed from an H+ ion and a polyatomic anion. So again, find that polyatomic ion sheet in the course information folder, or maybe you've got a physical copy of one. And you'll need to have this with you for any test that we take. So the names of ternary acids do not start with hydro. Even though their formula starts with hydrogen, the name does not start with hydro. It's just the polyatomic anion plus acid. But the first word ends in ic if the polyatomic anion ends in ate. So you need to look at, for example, if you're looking at the sulfate ion, then it's going to be sulfuric acid. If the first word will end in us, O-U-S, if the polyatomic anion ends in ite. So sulfite ion would make sulfurous acid. So the formula for HClO3, well, ClO3 is the chlorate ion. So HClO3, again, ClO3 is the chlorate ion. I happen to have that one memorized. You probably don't. You don't need to. But you should be able to look it up on your polyatomic ion sheet and see that ClO3 with a -1 charge is chlorate. Of course, that -1 charge got canceled out by the H+ here. So there's no charge in the formula. And then the name, we're going to take chlorate, and it ends in ate, so we're going to add the ic ending. So chloric, and then acid. And that's all. And the next one, H2SO4. SO4 - 2 is the sulfate ion. Takes 2 hydrogens to cancel it out because it's that -2 charge. So this is going to be not sulfate, but, well, sometimes people will say sulfic. Is it sulfic acid? It seems like it should be, but actually we call this one sulfuric acid. If you wrote sulfic, I probably wouldn't take off points. All right, the next one, HClO2, well, it kind of looks like the chlorate ion, but it's one less oxygen, so this is the chlorite ion. So this is going to be chlorite, ite becomes us, chlorous acid. Chlorous acid. And our last one is HClO. Well, that's like ClO3 is 8, ClO2 is ite. ClO is going to be 2 less oxygen, so that's hypoite. So this is hypochlorite ion. But if it's ending in ite, we use the us ending for our acids. So this is going to be hypochlorous acid. So that takes a little practice to get used to that. And it's a little strange because these formulas for acids with polyatomic ions in them, ternary acids, the formulas are longer than the ones we saw in the last slide, but the names are shorter because they don't start with hydro. So it's a little bit backwards from what you might think. Okay, lots more practice here, and these are all going to be acids that we're dealing with. I can tell by the fact that these all end in the word acid, so obviously those are, but these all start with hydrogen, so they're all acids. Okay, for hydrobromic acid, our cation is going to be H+. That's true for all of our acids. And because it starts with hydro, we know it does not have a polyatomic ion. So there's no polyatomic ion name to think about. So the cation is H+. The anion is going to be bromine. So we look up bromine on the periodic table. What's its charge? Its charge is -1. So we put the formula together, a +1 and a -1 make HBr. And that's that. Carbonic acid is going to have a polyatomic ion because it doesn't start with hydro. Of course, H+ is our cation. Oh, it's because it's carbonic acid. It ends in ic. Then it comes from the 8 anion. So carbonate is our polyatomic ion. We got our H plus carbonate. If you look it up on your chart on the table, it's CO3 minus 2. We put these together. We're going to need 2 hydrogens to balance out the CO3. So H2CO3. Hydrofluoric acid. It starts with hydro, so it is not going to have a polyatomic ion. Of course, H plus is the cation because it's an acid. It's always the cation for an acid. Fluoric comes from fluorine. Fluorine on the periodic table, it's a halogen. It's a -1 charge. And then we've got a plus and a minus. Put them together and you get HF. Okay, now we're given the formula and we need to write the name of the compound. Well, it's got 3 elements in it, so it's definitely a ternary acid. So it is going to have an anion that's a polyatomic ion on your polyatomic ion sheet, which can be found in your course information folder. H plus is still our cation. PO4 minus 3, PO4 minus 3 is going to be our anion. We're going to put those together to make H3PO4. And I'm going to pause there and start again. Okay, so we got our cation and our anion and the formula. The name for our anion is phosphate. Phosphate is PO4 minus 3. It's the one that's on your polyatomic ion sheet, listed as phosphate. And then we're going to write the name. It is not going to start with hydro because this is a polyatomic anion. So it's going to be phosphoric because it's 8. 8s become ic. Phosphoric acid. And again, it's a little bit hard to tell where you cut off the word phosphorus to add the ending. So for the ic ending, we cut off phosphorus to make phosphoric. But for phosphate, it comes from phosphorus, phosphate. We cut it off kind of early. So that's a little strange. It's a little tricky. Most things you're going to be looking at will be multiple choice or drag and drop kind of stuff. But if you had to write those out and you spelled them a little bit wrong, as long as you had the right ending, I would be not concerned about that. Okay, H3P, our cation, of course, is H plus. Our anion is phosphorus by itself. So we got to look up that element on the periodic table. It's in the -3 column, which of course that makes sense because it takes 3 hydrogens to balance it out. It does not have a polyatomic anion at all. So phosphorus here is not polyatomic. So then the name is going to be, if it's not got a polyatomic ion, it's going to start with hydro, and then it's going to be this element, and then ic, and then acid. So this will be hydrophosphoric acid. So here's phosphoric acid, here's hydrophosphoric acid. Again, the one with the longer name has the shorter formula. Okay. If you had H plus and S minus 2, you would get H2S to balance the charge. Because S is not a polyatomic ion, we're going to start this with hydro and end with ic acid. So this is going to be hydrosulfuric acid. And the next one, we have H plus and SO3 minus 2. So this is going to be H2SO3. Now, what is the SO3 polyatomic ion? If you look it up on your sheet, you'll find SO4 minus 2 is sulfate. So this has 1 less oxygen, so it's sulfite. Ite polyatomic ions get their name changed to us. So this is going to be sulfurous acid. Not sulfuric, because ic comes from 8 anions. Us comes from ite anions. Then on the last one, we have H plus, and then this big thing for our anion, C2H3O2 minus. Sometimes those letters are written a little bit differently. Sometimes it's C2H2OOH based on the structure of the formula. But that's okay. Either way you write it is okay as long as you've got the same number of each letter that you're supposed to have. That anion is known as acetate. Acetate. So it's an 8 anion, so it's going to become an ic ending. And because it's a polyatomic ion, we don't start with hydro over here in the name. So it's acetate-ic acid. Well, it's acetic. Acetic is how we say that. Acetic acid. And acetic acid is the main compound in vinegar. All right, that's it. So go back through, watch again, review if you need to. Make sure you go back and write down the details, knowing which ones start with hydro and which ones don't, how you know an acid from a base, and then what are those endings going to be changed to? Are they always ic? When are they us? So go through and review that. Make sure you've got it all written down. And then give those check for understandings for today a shot and see how you do. You get 3 chances. If you have any questions, come see me in the WebEx, and I'll talk to you soon.